Hello, hi everyone. Welcome to the Student Brand. This is our Shiva sir. Today topic is electric current. So we can see electric current. Electric current. Electric current. In this topic, so we are discussing electric current. So here, or simply we can say electricity. So in this, what are the points we'll discuss? Electric current, electric current, electric current. So what are the contents we are going to discuss? Second one is charge, and third one is electric potential and potential difference. Electric potential, electric potential and potential difference. Potential difference. And fourth one, we can see electrical components. Electrical components. Electrical components. Fifth one, so Ohm's law. Ohm's law. Ohm's law. And sixth one, resistance. Resistance and factors. Resistance and factors. And the seventh one, resistivity. Resistivity. And eighth one, resistance and resistivity difference. Resistance and resistivity difference. And the ninth one, we can see resistors are in series. Ninth one, resistors are in series. Resistors are in series. Resistors are in series. And next one, resistors are in parallel. Next one, resistors are in parallel. Resistors are in series. Next one, 10th one, resistors are in parallel. Resistors are in parallel. So these points we'll discuss. And still it is there, electrical power, heating effect of electric current, and applications of heating effect of electric current, and all the formulas. So we'll discuss all the points. First of all, so main points. So these are the main points. Two more points are there. So I'll explain. So you can work out now. Okay. So now we can see electric current. So these 10 points we'll discuss briefly. So those are there in live class. So those are after the live class, if you are watching. So just you can focus on the points. So I'll be giving notes also, important points and formulas, and explaining the topics in detail. So in depth also. So stay focused and observe. Make a notes. So it will be helpful. If you write a note while listening the class, it will be good. So automatically after the class, once again if you go through the notes, it will be okay. So usually you can recall the topic. So now we'll go with the electric current. So electric current topic. So what is electric current? Electric current is nothing but the rate of flow of charge. So I equal to Q by T. I equal to Q by T. So that is nothing but rate of flow of charge. Rate of flow of charge you can consider, that is electric current. Electric current. So what is that? Rate of flow of charge. I equal to Q by T. I equal to Q by T I am considering. So here SI unit of current is ampere. SI unit of current is ampere and SI unit of charge is coulomb. SI unit of charge is coulomb and SI unit of time is second. SI unit of time is second. So here you can observe. So electric current is nothing but rate of flow of charge. Rate of flow of charge. So I equal to Q by T. So here is a charge I am considering. So SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. So 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. So 1 ampere is defined as the 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross sectional area per second. That is nothing but 1 ampere. So 1 ampere equal to 1 coulomb per 1 second. So that is nothing but electric current. So what is the device used to measure the electric current? Ammeter. So ammeter is the device. Ammeter is the device used to measure the electric current. So here ampere. So ampere small letter. So starting letter small letter you have to write. On honoring the scientist, we are using the unit as small letter. Starting letter small letter. But while representing the unit, while representing symbol, you can write capital A, ampere. So you can write capital A. So here I have written. So 1 ampere equal to 1 coulomb per 1 second. So what is which device is used to measure the electric current? Ammeter. Ammeter is a device used to measure the electric current. Okay, so these are the points, and here one point is there, that is the charge. So we have to discuss about charge briefly. So make a notes while writing. I'm saying make a notes, then it will be good to you. Okay, so now we have to talk about charge. Charge is nothing but it's a property of the matter. So charge is nothing but property of the matter. So I'm considering Q. Q is a charge. Charge is a property of the matter which influence the presence of other charges. So if I'm taking this a charge, so around it, if any charge is there, it will influence. So it's a property of the matter. So there are two charges are there. One is positive charge, another one is negative charge. Positive charge and negative charge. Okay. So positive charge will repel each other. So repel each other. So whereas positive charge and negative charge attract each other. So both will attract. So positive charge, negative charges. So two opposite charges attract each other. Two similar charges. So negative, if you are taking negative will repel. So positive will repel. So positive, negative, positive will attract. So it relates to attract. So based on this one, they will ask the one MCQ. So keep in mind this point. So there are charge. What is the charge? Charge is a property of the matter which influence the presence of other charges. There are two types of charges are there: positive charge and negative charge. So positive charge. So positive charge repel. Negative charge repel, and positive charge, negative charge attract. Negative charge, positive charge attract. Negative charge, positive charge attract. So that is about charges. And charge of an electron. So positive charge is proton. So I am considering the positive charge is proton, and negative charge is electron. So positive charge is proton, negative charge is electron. So charge of an electron is 1.6 into 10 power minus 19 coulomb. So charge of an electron is either positive or negative. If it is proton, so we can take 1.6 into 10 power minus 19 coulomb. Positive we are considering. If it is electron, minus 1.6 into 10 power minus 19 coulomb. Charge on electron. So charge on electron. So we can say 1.6 into 10 power minus 19 coulomb. Okay. So we can take 1 coulomb equal to. So in 1 coulomb, how many electrons are present? So if you are taking 1.6 into 10 power minus 19, that is nothing but 6.25 into 10 power 18, 10 power 18 electron, 10 power 18 electrons in 1 coulomb of charge. In 1 coulomb of charge, how many electrons are present means this many electrons are present. This many electrons are present. 6.25 into 10 power 18 electrons. So this is very, very important. So keep this mind. So these 2 points. So this is 1 point and this one. So very, very important. 1 mark question will come. This is 1 mark. This is also 1 mark. So charge 1 mark. So question. And previously explained it, electric current 1 mark they will ask. So electric current definition and definition of 1 ampere 1 coulomb per 1 second. So this one and 1 I equal to q by t, I equal to q by t. So 1 mark. So this also 1 mark. So this is the definition. 1 ampere equal to 1 coulomb of charge flowing per second. 1 coulomb of charge flowing per second, or 1 ampere is defined as 1 coulomb of charge flowing unit cross sectional area per second. So if you are taking conductor will be like this, right? So this is the area of the cross section. 1 unit of cross section area I am taking 1 meter square. So that's why 1 ampere current is defined as the 1 coulomb of charge flowing through unit cross section area per second. So in 1 second, how many electrons will pass? How many electrons will pass? That is called 1 ampere. So that is nothing but electric current. I equal to q by t. So the rate of flow of charge. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. So and here this point is very, very important. Charge on electron 1.6 into 10 power minus 19 coulomb. So 1 coulomb equal to, so 6.25 into 10 power 18 electrons. How many electrons are present means this many electrons are present. So this is a brief explanation, brief idea about charge. So I hope you got it. So note down. So make a note. So pause this video. Make a note all the points. Clear? Done. Next one. So we'll go with the electrical potential. So first of all, we'll discuss about potential difference. So what is the potential difference? Potential difference is nothing but, so this is the conductor. Within the conductor, I am taking this point A and point B. So I am considering the positive charge. Okay. Positive charge I am considering. So we are doing some work. To bring this positive charge from point A to point B. So work done to bring unit positive charge from point A to point B within the conductor, or from one point to another. So work done to bring unit. So electrical potential is nothing but, so here by seeing the formula itself we can tell the definition. So work done to bring. So potential difference is nothing but work done. So W is the work, Q is the charge. Positive charge I am considering. V is the potential difference. So work done to bring unit positive charge from one point to another. So potential difference is nothing but work done to bring unit positive charge from one point to another. So potential difference is nothing but work done to bring unit positive charge from one point to another. That is called potential difference. So SI unit of potential difference is volt, and SI unit of work done is joule. SI unit of charge is coulomb. So these are very, very important. Each and every time whenever you are learning the particular concept, you must understand the SI unit also. This is about potential difference. And coming to the electrical potential. So here the difference is, so electrical difference and potential difference. Only one point, nothing else is there. So electrical potential. So electrical potential is nothing but, so here is the charge, positive charge. So I am taking this infinity. So this is the required field. So we are doing some work to bring unit positive charge from infinity to the required field. from infinity to the required point. Okay, so electrical potential is nothing but work done to bring unit positive charge from infinity to the required field is called electrical potential. So formula is same, SI unit same, everything is same. So 1 volt equal to 1 joule of work is done to bring 1 coulomb of charge from infinity to the required field. So that we can consider as a electrical potential. So I hope it is very clear. So that is about electrical potential and potential difference. And SI units are same. SI unit and SI unit, everything will be same. Okay. And coming to the next one, only definition. So definition will change. So there electrical potential difference means work done to bring unit positive charge from one point to another is electrical potential difference. One point or another is potential difference. From infinity to the required field is electrical potential. And coming to the electrical components. So electrical components. What are the electrical components? So we'll discuss now electrical components. So those are, okay. So here I am considering this cell. One positive terminal, another one negative terminal. This is called cell. First one. Second one, if you consider one positive terminal, one negative terminal, so two or more to be connected, that is called battery. So here I am considering the battery like this. This is a battery, cell and battery. And third one, if you consider switch, this is the switch. This I am considering. So actually the dot is not there. This is the open switch. Open switch. And fourth one is closed switch. I am considering this thing, closed switch. So cell, battery, open switch and closed switch. Then we'll go with that so 1, 2, 3, 4, 5. Fifth one is we can take a resistor. This is the resistor symbol. And the sixth one is, so we can consider this is the rheostat. Either we can take like this, So rheostat. Okay. So seventh one is ammeter. So I am considering this ammeter, positive terminal, negative terminal. So this ammeter. So we can also consider one more. Ammeter I am considering. So this ammeter. Next one is voltmeter. Seventh one, eighth one. Eighth one is voltmeter. So I am considering the voltmeter. Next one, ninth one. So wire joining. This is wire joining. 10th one, wire crossing. So this is wire joining. This is wire crossing. Okay. So this is about and a bulb. So bulb. So we can consider the bulb like this. So if it is like this, it's a glowing bulb after connecting. Normally this is the bulb. This is a wire joining. This is a wire crossing. Okay. That is about. Next one. So this is about electrical components. Clear? Now we'll go with that. Ohm's law is nothing but, so we can see Ohm's law. If you are taking, yes, correct. Now I am considering the Ohm's law. Will go with the Ohm's law because remaining points are there. I am talking about we'll go with the Ohm's law. So Ohm's law is nothing but the potential difference across a metallic conductor. So I'm considering this so this is a resistor. So across this one potential difference is there. So I'm considering this a potential difference. So this is a resistor. Resistor here is the nichrome wire. Nichrome wire. So I'm considering nichrome wire. Nichrome wire I'm considering. Okay. So the potential difference across a metallic wire is directly proportional to current flowing through it. So it's directly proportional to current flowing through it. So V is directly proportional to I. V equal to IR. V equal to IR. Statement is nothing but the potential difference across a metallic conductor. So or metallic wire. So potential difference. So potential difference. So voltmeter is used to measure the potential difference. Voltmeter will be connected parallel to the components, electrical components, because it measures the potential difference. Okay. Ammeter is used to measure the current. So what is use of ammeter? Ammeter is used to measure the electric current. Okay. So it's related to current. So it will be connected series to the circuit. Series to the circuit. SI unit of current is ampere. So that is nothing but ampere. Okay. So it measures the current as I said. So voltmeter. Voltmeter is nothing but, so I am considering the voltmeter like this. So positive terminal, negative terminal. So it is measures the potential difference. It measures the potential difference. It measures the potential difference. Okay, potential difference. And so it connected parallel. So it will be connected parallel to the circuit. And SI unit of potential difference is volt. SI unit of potential difference is volt. Okay. Yes, Soham. So that is correct. So the potential difference across a metallic wire is directly proportional to, or across metallic we can consider, or across 2 points. So we can also take. So between the 2 points also we can consider. So it is directly proportional to current flowing through it. V is directly proportional to I. V equal to IR we are considering. Okay. So here R equal to from this one I equal from this one R equal to V by I we can also take. So here, so Ohm's law gives the definition of resistance. Ohm's law gives the definition of resistance. So as I said, potential difference across a metallic wire is directly proportional to current flowing through it. V is directly proportional to I. So V equal to IR, I equal to V by R equal to V by I. V by I am considering. So this is a resistance. So Ohm's law gives the definition of resistance. So this is about the statement I am considering. This is about statement. Okay, statement. And coming to the thank you, Saham. Very good. So thank you being as an observer. So here I am considering the nichrome wire. Okay. So nichrome wire I am considering like this. So here I am taking. So required materials. So what are the materials required? One. So 1.5 volts of 4 cells. 4 cells. 1.5 volts of 4 cells. And the second thing is nichrome wire. Nichrome wire. Nichrome wire of 0.5 meter length. 0.5 meter length. So ammeter and voltmeter are there, that's why I'm using symbols. You can write with the words. Okay, here you can take. So ammeter, voltmeter, and fourth one is connecting wires also we can take. Nichrome wire already I consider, and switch we have to take. Switch I'm consider. So here is ammeter and here is a switch. So here is considering. Here I am taking like this. So one cell and the second one, third one, fourth one I am considering like this. So positive terminal, negative terminal. So here 1.5 volts, 1.5 volts, 1.5 volts, 1.5 volts. How many are? 4 cells. So I connected 4 cells, and here we have to take the wire here from here. Why? Because we are showing we are this is an activity. So we are doing an activity one by one. We are connecting. So that's why first we have to connect one cell, then another, so then another, like this we have to connect. That's why we are showing with the dotted lines. So anyway, current will pass from positive terminal to negative terminal. So that is a conventional current and electric current. Conventional current is nothing but the flow of positive charges. So the direction of flow of positive charges is called direction of flow conventional current. So conventional current is nothing but before finding electron, proton, neutron. So already they given the statement. So the flow of positive charges. So that is called electric current. So here we are using the conventional current. Electric current is nothing but flow of electrons. Flow of electrons. Electrons will move from negative terminal to positive terminal. But current direction we are considering from positive terminal to negative terminal. Positive terminal to negative terminal. So here I am considering, so voltmeter, ammeter, switch. So represent with K. Key also we can say. And 4 cells I connected to the Y. Now, so these are the requirements. 1.5 volts, 4 cells, nichrome wire. Nichrome wire is a combination of nichrome wire. So I hope it is clear. So I'm rubbing this one. So we can change this one. Nichrome wire is an alloy of nickel, chromium, manganese and iron metals. Nichrome wire is a so we can say nichrome wire. Nichrome wire is a combination of nickel, chromium and manganese and iron metals. Okay, so here I am considering like this. So nichrome wire is a combination of nickel, chromium and manganese and iron metals. Nickel, chromium, manganese and iron metals. So it is an alloy. So here we are using as a resistor. So here we are using as a resistor here. Resistor, nichrome wire as a resistor. The materials required. So this is the circuit diagram, the logical connection of electrical components. So in a series combination, logical connection of electrical components in series combination. So that is called a circuit diagram or a schematic diagram. Schematic diagram also we can say. So this is a schematic diagram or circuit diagram. We can consider circuit diagram, circuit diagram, circuit diagram. So this is about materials required. 1.5 volts of 4 cells, nichrome wire, ammeter, voltmeter, switch I am considering. So that is a closure switch. Current is passing through that one. First we have to connect one cell. Procedure. So what is the procedure? So procedure is, so we have to follow first. We have to connect. We have to take one cell. Connect one cell. First connect one cell and take the reading of ammeter and voltmeter. So ammeter and voltmeter we have to take the so this is the tabular form. So I'm considering like this. So serial number of cells, how many cells we used, and ammeter reading. So ammeter reading, that is nothing but current. So voltmeter reading, that is nothing but potential difference, and V by I. So that is nothing but resistance. V is directly proportional to I. So V equal to IR, and R equal to V by I, right? So V by I. So we are finding the resistance. So R equal to V by I. So V is directly proportional to I, V equal to IR. So now serial numbers. So how many cells we used? So how many cells we consider? 4 cells. So 1, 2, 3, 4. Okay. and serial numbers, cells also same. Here, first process is, first you have to connect one cell and take the reading of ammeter and voltmeter mentioned in the tabular form, and connect to two cells. So second step is connect to two cells voltmeter and mention in the tabular form, and repeat the process for 3 and 4 cells also. So 3 and 4 cells also, 3 and 4 cells also, and take the reading of ammeter and voltmeter and mention in the tabular form, and then so we can get resistance, so R. Okay, if you draw the graph for this values, so the graph, okay, so I hope it is clear. Once again I will be explaining, just check once again I'll explain. So Ohm's law is nothing but the potential difference across a metallic wire is directly proportional to current flowing through it. So V is directly proportional to I. So V is directly proportional to I. V equal to IR, R equal to V by I, and materials required. So this is circuit diagram, connection of all the electrical equipments in a series combination. The logical connection of electrical components in a series combination. So logical means we have to connect here positive, negative. So here positive, negative, like that we have to connect. However, which we can't connect. That too all must be in series combination. Okay. So that is about schematic diagram, and materials require 1.5 volts 4 cells, nichrome wire. A nichrome wire length is 0.5 meter, ammeter, voltmeter, switch and connecting wires also we have to consider connecting wires. So procedure is take one cell and connect the reading, connect one cell and take the reading of ammeter and voltmeter and mention the tabular form, and connect to two cells, and take the reading of, repeat the process for 3 and 4 cells, then you can mention in the tabular form. If you draw the graph, VI graph for this one, then we'll get that is nothing but ohmic conductors. So I'm considering, so ohmic conductors means the substances which obey Ohm's law, those are called ohmic conductors. The graph for VA is, so V on y axis, this is y axis, x axis current on x axis. If you draw the graph, it will become linear. So whereas this is for ohmic conductors, non-ohmic conductors it is curve. Non-ohmic conductors it is curve. This is the ohmic conductors. So the substances which obey ohmic conductors, the substances which obey Ohm's law, those are called ohmic conductors. Non-ohmic conductors means non-ohmic conductors, the substances which does not obey Ohm's law, those are called non-ohmic conductors. Here ohmic conductors means, as I said, ohmic conductors graph is so straight line linear. So they will ask 1 mark for 1 mark this graph, very very important. Okay, non-ohmic conductors also very important. This is about ohmic conductors and non-ohmic conductors. Okay, next one, coming to resistance. Resistance directly proportional to length of the conductor. Resistance is directly proportional to length of the conductor I am considering. So R is directly proportional to L. R is inversely proportional to area of the cross section. R is directly proportional to L. R is inversely proportional to area of the cross section. So R, if you consider, so L by A. So R equal to rho into L by A. So I'm considering. So rho is the resistivity. So rho is the RHO resistivity. So whereas resistance, R is a resistance. So resistance is nothing but the phenomena of opposing the electric current in the circuit, that is called resistance. So SI unit of resistance is ohm. So SI unit of resistance is ohm. Symbol, if you take, this is symbol. Symbol, I am considering this is symbol, and this one is the SI unit. SI unit of resistance. SI, and the device which is opposing the electric current in the resistor is the device which is used to oppose the electric current in the circuit is resistor. So resistance is the phenomena. SI unit of resistance is ohm. Symbol is this one. Okay, so that is about resistance. Resistor R is directly proportional to L, R is inversely proportional to area of the conductor. Inversely proportional. So R is directly proportional to L by A, R equal to rho into L by A. Rho is the resistivity. Clear? That's enough. So next one, difference between resistance and resistivity. Difference between resistance and resistivity. Here is the resistance, and coming to resistivity. Resistivity. So R is R equal to rho into L by A. So here rho equal to RA by L. So second one is SI unit of resistance is ohm. Symbol. So here SI unit of resistance is ohm meter. So we can say, we can take like this, ohm meter. Ohm meter. And third one is symbol, already we discussed. So it depends on length. Resistance depends on length and area. Resistance depends on length and area. Does not depend on physical dimensions, length and area, or physical dimensions also we can say. And fourth one, it depends on temperature. Depends on temperature. So fourth one here, it is also depends on temperature. Depends on temperature. Okay, on temperature. Resistivity also depends on temperature. And fifth one you can see. So it depends on material also. Material. So fifth one here. So it also depends on material. Once again. So resistance, if you are taking resistance. So resistance is nothing but the phenomena of opposing the electric current. Resistivity is nothing but resistance of the conductor per unit length and unit cross sectional area. SI unit of resistivity is ohm meter. SI unit of resistance depends on length and area. Resistivity does not depend on length and area or physical dimensions. Resistance depends on temperature. Resistivity depends on temperature. Resistance depends on material of the conductor. Resistivity also depends on material of the conductor. So these are the points. So I hope it is very clear to you. So next one. So next one we'll go with that resistors are in series. Next one, resistors are in parallel. Resistors are in series and resistors are in parallel. Resistors are in series. Resistors are in series. So I'm considering like this. Okay. So Ohm's law. What is Ohm's law? V equal to IR. So keep in mind. So Ohm's law. So here I'm considering one resistor, another resistor, another resistor. So I'm taking three resistors. If you connect three resistors in such a manner, so I'm considering this a starting point and ending. So starting and ending. If you connect in such a manner, ending point to starting point, ending point to starting point, or so current in a circuit. So current in the circuit is same throughout the circuit. Current is same in the circuit, then that type of connection is called series connection. So I'm considering this R1, R1, R2 and R3. So three types of resistors. So I'm considering here a battery, a switch. Okay. So current will pass like this. I'm taking. So across this one, I'm considering a V1, across R2, V2, across so this R1, R2 and R3. So across resistor R1, V1 I am considering, across R2, V2, across R3, V3 I am taking. So these are the three resistors. Current is passing from Ohm's law. We are considering V equal to IR. V equal to IR. Current is passing, right? Now, so throughout is same. Then potential difference is different. So Vs or Vq equivalent resistance or total potential difference. Equivalent potential difference or total potential difference. Vs equal to V1 plus V2 plus V3. V1 plus V2 plus V3. So we can take IRS equal to IR1 plus IR2 plus IR3. How you got this one? From Ohm's law, Vs equal to IRS, because current is same throughout the circuit. That's why I am not writing IRS, I1, I2, I3. I am not writing anyway. So if you take Is equal to I1 equal to I2 equal to I3 equal to I, because current is same throughout the circuit. That's why I am not writing. So simply I am mentioning I. So from here, so RS if you take, RS I am considering, I if you take common, R1 plus R2 plus R3. So I get cancelled. Then RS equal to R1 plus R2 plus R3. So note down this one, circuit diagram and everything. So just take 5 minutes break. 5 minutes break. So I'll come back. Okay. So just come back. Just take break and note down. So, hi everyone, welcome back. So now you can see resistors are series. Resistors are in series. So R1, R2, R3. So across R1, R2, R3, I am connecting V1, V2, V3. Okay, so current is passing, current is same. So I1, Is equal to I1, I2, I3, I plus V2 plus V3. So from that we can take I common, I get cancelled, we'll get, so Rs equal to R1 plus R2. So if you are taking number of resistors, if so n number of resistors are connected in series, so then we can take NR. So the formula, if n number of resistors are connected in series combination, then we'll use this formula. Okay, so that is about resistors are in series. Coming to resistors are in parallel. Resistors are in parallel. So we'll work out on it. Resistors are in parallel. So how it will be? Resistors are in parallel. So from Ohm's law, V equal to IR, I equal to V by R. So I am considering one resistor like this. This is one resistor, one more resistor, and one more resistor. So in this way, if you connect, so this is the R1, R1, R2, and R3. So across this R1, R2, R3, so I am connecting voltmeter. So I am connecting like this. Okay. So here I am connecting now. So that will be connected to the circuit. So positive terminal, negative terminal, current is passing. Okay. So here positive, negative. So the current is passing. So it is dividing I1, I2, and here I3. I1, I2, I3. So current is dividing into three parts. So from here, potential difference across three resistors, potential difference is same. Across three resistors, potential difference is same, current is different. Then IP equal to I1 plus I2, IP equal to I1 plus I2 plus I3. IP equal to I1 plus I2 plus I3. Then we can take so V by RP. V by RP equal to V by R1 plus V by R2 plus V by R3. So we can take V common. V you can take common, 1 by R1 plus 1 by R2 plus 1 by R3. So V will get cancelled. 1 by RP equal to, so 1 by R1 plus 1 by R2 plus 1 by R3. So this is about resistors are in parallel combination. Resistors are in parallel combination. So if they are connected in parallel combination, then we can take R by N. So normally 1 by RP equal to N by R. So RP equal to R by N. So this about resistors are in parallel combination. So I hope it is clear. Next one, electrical power. Electrical power or heating effect of electric current. So we can say heating effect of electric current. Okay. So now we can take this also heating effect of electric current also. In that part only it will come like this. So we know work done to bring unit positive charge. So I'm considering VQ, sorry, V by W by Q. So we know potential difference. Potential difference equal to W by Q. W equal to V into Q. So we know rate of doing work is called power. Rate of doing work is called power. So in the work done, so we can substitute in the place of work. You can substitute, but then we'll get V into Q by T. So what is V into Q by T? Q by T. So we know Q by T is rate of flow of charge. That is nothing but current. And then VA. So P equal to VA. So this is electrical power. We know electrical energy. So P into T. Okay. So that is nothing but VI into T. So whatever the energy is given or produced in the conductor, that will become in the heat. So that will outcome. That will come out as a heat. So that is nothing but so we know V equal to IR. V equal to IR from Ohm's law. So from here I into R into I into T. So that is nothing but H equal to I square RT. So this is nothing but heat produced in the conductor. Joule's law of heating. So heat produced in the conductor is directly proportional to square of current. Heat produced in the conductor is directly proportional to resistance. Heat produced in the conductor is directly proportional to time. Okay, so that is about electrical power and the heating effect of electric current. Best example actually it is the part of heating effect of electric current. So this is electrical power. From here itself we get electrical power. So heat produced in the conductor is directly proportional to square of current, directly proportional to resistance, and directly proportional to time. So this is about heating effect of electric current. Applications of heating effect of electric current is nothing but, so where we are using electrical kettle, electrical oven, okay, so like this, and heater, like this, all the examples. So and electrical cooker. So in all the ways, in all the areas, so heat will be produced. So the source of energy continuously gets dissipated entirely in the form of heat. That is nothing but heating effect of electric current. The source of energy continuously gets dissipated entirely in the form of heat. So that is nothing but electrical heating effect of electric current. So that's enough. So this is about electric current. If you like this video, if you like this lecture, if you like this teaching, so do like, share and subscribe to Student the Brand. Please do like, share, and subscribe my channel. My channel, Student the Brand. Student the Brand. Student the Brand. This is my channel. And so courses I'm giving. So CBSE grade 10, CBSE grade 10, grade 10 physics, grade 10 physics course I'm giving. So four chapters, light reflection and refraction, human and color fluid, magnetic effects of electric current and electricity. And these four chapters and soft copy notes also I'm providing, soft copy notes. Okay, so explanation, live class explanation I will be giving, and also so whatever the doubts you have I'll be clarifying, and 100 definitions from these four chapters, 100 definitions from these four chapters, 100 definitions, and fourth one, 100 problems from electricity chapter, 100 problems from electricity, different models. So I'm covering this all, I'm giving with the cost of 500 rupees. With the cost of 500 rupees I'm giving. Okay, so with the cost of 500 rupees. So those who want this course, you can contact this number 9849812804. So you can contact to this number to get this course. So if you have any queries regarding the physics CBSE grade 10, so you can ask me regarding any doubts, any clarification, or any topic you want explanation, you can contact to me through this number. So WhatsApp is there to this number. So thank you so much. So please do like, share and subscribe to Student the Brand.